This is a core VLSI concept and one of the favorite questions in interviews. In our designs, especially for clock network or clock cells, we want the rise time to be equal to the fall time because otherwise it can cause issues with respect to duty cycle distortion or min pulse width violations, which we will discuss in later videos. So often we are asked how to size the PMOS and the NMOS with respect to each other, and the answer comes from the fact that we want to maintain the rise and the fall times as equal. The rise time is when the signal goes from 0 to 1, and it happens when the current flows through the PMOS. And the fall time is when the signal goes from 1 to 0, and it happens when the current flows through the NMOS. And we know that for a RC circuit, the rise time and fall time are given by R multiplied by C. So the rise time through PMOS will be equal to R of PMOS multiplied by C load, and the fall time through NMOS will be equal to the resistance of NMOS times C load. So all we need to do is to make R of NMOS equal to the R of PMOS. So just as a rule of thumb, if our NMOS and PMOS are of the same width, then PMOS resistance will be 1.5 to 2x that of an NMOS, and that is because the mobility of electron is usually considered to be 1.5 to 2x times more than that of a hole. So based on this, we can say that if the width of our NMOS is W, then we have to make PMOS twice as wide so that its resistance will become equal to that of a NMOS. So to answer this question, we can say that because we want to make the rise time and fall time equal, and because the mobility of electron is twice that of a hole, we have to make PMOS as 2x width of that of an NMOS. So that's how the transistor sizing will be done in case of this inverter.